Do the screen share.
And they're going to Cascade.
What's this thing? Oh, I can like draw on it.
Yeah.
I have to use the smart board, you can do that anyways. If you use smart board.
Yeah. Okay.
Is it the infinite tunnel of doom?
It's like black hole is constructed, no one knows.
Yeah.
So, like, I really like that site you have me check out, but they have been spamming my inbox.
Oh yeah.
Like the first day, they're like, "Here's 40."
Which one did I give you?
Zoho.
Okay.
They're cool though. I like it. It's like, okay, you can stop emailing me now.
So since you brought it up, let's talk through this homework too. So this is due next Tuesday, so I moved kind of quick on it, but I don't think it's very hard. It shouldn't take you very long. So the first part is just it's one problem from chapter 5 and 3 problems from chapter 6. That's 40 points.
Is that correct from the email you sent out?
Yeah, because it was 5, 8, 8
Okay.
on the email. The last one was an 8 instead of a 9. And then the middle part is that I assign each of you down here one of those project management softwares. I gave you Microsoft Project since I knew you had it and I knew you kind of knew a little bit about it. So I didn't want to give it to someone that would have to go search it out. If you guys want chocolate chip zucchini bread,
Are you gonna hit us like
good.
you-
I got it. There's a knife here. You can help yourselves. My wife made it last night. It's really good.
She I think more of that pumpkin bread. That was delicious.
I think this might be even better. It's chocolatey, but that pumpkin stuff was pretty good. So
What, cream cheese frosting on, or was it sour cream?
it was cream cheese. Yeah, it was good. I gave Damon Bitrix 24. I think that's the only one that wasn't in my other lists. I think I had 8, and then I added this Bitrix and the project. Let's just make sure this still looks like it's going.
I'm
Yeah.
sure you're broadcasting.
Yeah,
I did.
Check that one.
So you're going to kind of address these bulleted points as you look at the software. You're going to create an account. They should all have free accounts. I'm pretty sure I checked them all. I want you to just kind of say, like, the overall here, discuss the overall usability. Like, did you like it? Was it awful? I mean, if it sucks, just tell me, because I want to know. Would you recommend someone to use it? And then you get into the specific points. So for planning projects, can you give a detailed breakdown of tasks to be completed? Can you assign tasks to people who will be responsible for them? Can you give a time estimate? And can you link dependent tasks? This is kind of like, does it have a Gantt chart or some other way to accomplish what the Gantt chart did? For managing tasks, there's some overlap between planning and managing tasks. Defining tasks, assigning someone, create a deadline, know when it's complete. There's kind of an overlap here, but so does it support network graphs and Gantt charts like we talked about, or is it Kanban? Like we know Trello is Kanban. We looked at that. Some way for dealing with the tasks and scheduling them. Does it have a place to share documents amongst a team? That's not as important for like our use, but if you are working in a team, of course you can use Google Drive or any number of things, but it's kind of nice if
you need a project.
If everything's sort of in the same place and you don't have to use 5 different apps to do it.
On the Zoho one, if you upload it and you log in, it's like, hey, so-and-so uploaded this file about the project. It's right here, like right.
Oh, so that's awesome. So you know you don't miss it. Yep. Does it have issue tracking or bug tracking? Now I put here, no, this is often accomplished through a separate tool. It won't surprise me if almost none of these have bug tracking.
You have to pay like $15 extra.
It does have it though, which isn't bad if you were using it like for a business. It is useful if you're working on an ongoing software project with tasks, you're going to have a bug tracker. So you fix things as you go. Well, if you if it's not in this tool, you're going to have to use a separate one. And then does the software track the time team members are devoting to each task? A lot of times this is important for billing. How many hours are you working on specific tasks? And if you can create tasks, it's nice if you can track time to the task. We estimated it was this long, but we took this long. That's pretty useful. So Tom has project. You have Asana. Make sure I didn't get any duplicates. Nope, I think we're good. So I don't think that's super difficult. Just kind of mess around with it. I'll take the feedback from what you guys see, narrow it down to the top ones that sound the best, and then I'll go in and do a more detailed. I just didn't want to have to go into 10 things myself and look at them. I think this is good practice anyway.
Like right off the bat, the Zoho one is like so easy to use.
Yeah, that's good. Some of these can be a real pain, I think, because there's so much functionality, and like there's a fine line between providing great functionality and then just making it so difficult to figure it out. Like I've noticed that with some of these softwares, so maybe Zoho is a good one. The last part, 20 points. In order to start thinking about your capstone project, write a description of what you are thinking about developing for this course. So I put, no, this is very initial idea, just to get, you give me something and then I can give feedback back. You're not tied to this. If you say you're going to do one thing and then you change your mind, that's fine. I just want to get the wheels rolling. So my guidelines to work with for this first part: think about a problem you've had in a business you've worked for, or just life in general. Now think of a software-based solution to the problem. And then that's what you're going to implement. So it can be a big problem and you do part of it, because if it's a big problem, you're probably not going to have time to develop it, right? But it can be a small problem. Things that have been floating around, we talked about Damon's brain scanner. A website to catalog memes is another one that's been floating around. That could be a problem. There's not a good website to store memes.
Facebook, memes.com.
So, I mean, I'm being pretty open-ended on this. I mean, I'm not tying it to be like it has to match this book that we're implementing an information system solution. Some people likely will, but you don't have to. Your software should be able to persist data. I mean, that's almost goes without saying, because it's not really a system if it can't, but you should probably have a database. You could write to a flat file, but I think that's harder than just using a database, personally.
What do you mean by like flat file, like a file system?
Like it's a TXT file that you write data, or an XML file you write and read data to and from.
I think that's actually a little bit easier.
XML can be pretty easy because it's structured.
Because they're using the Java with the XML and you just output the text file, it's like super easy.
If you just serialize it in Java, have you ever done serialization? So say you have all these objects instantiated with data stored inside of them, you can use a serializable class, and then it just outputs an XML file that then you can read in, and all those objects that were instantiated will come back exactly how they were, which is awesome. I've done a whole project that was based on that very idea for persistence.
Because I use almost like the same thing I use for your PHP thing in Java format, and I just have everything in a folder.
Yeah.
It's all just ready.
Yeah, so I mean, if you want to do it that way, that's fine. It probably is easier to you because you don't have as much experience with databases. Of course, I'm going to say, well, the database is the easy way, but I have a lot of database experience, so yeah.
So basically, we're going to be making like a website or an app or something.
Mm-hmm. And my next bullet point, as you brainstorm your idea, don't limit it based on what you think you actually can create, because like we've talked about, we have varying levels of development skills. Do think about scope, though. Try to think of something not huge, like you're not going to design banking software, like something that's the scope is feasible. We'll worry about figuring out how to implement it down the road. You'll have 10 or more weeks to work on it. We're in week 3. Within 2 weeks, we'll finish up the book of what I want to do and move into the project. So that's a lot of time, 2.5 months to work on it. And then if you don't have an idea of what you want to develop it in, so I say here, maybe a website, a desktop application, an app, you can pick the technology and platform. If you don't know what technology you want to use, I can help you figure that out. So don't brainstorm based on, well, I only know how to program in Python, so I have to think of something I can do in Python, which could be kind of limiting. I think for some of these websites are probably in some ways the easiest, but it just depends. If you have some Java programming experience or something, then that's accessible. So we'll figure out a way to make it happen. And we're not talking that you're going to come in, because at the end you're going to present these to the class, not with some like polished awesome thing, like a prototype. So remember, we don't have a final, and I'll be gone the day we're supposed to have the final. We'll pick a time during that week by poll, what can fit, and we'll take like 2 hours and we'll show off our projects. That'll be our final. So
presentations by webcam.
We'll probably patch in the people that can't be here through webcam.
This is a picture of Aaron Steve.
If we do it in the evening though, or something, some of the people that have jobs could come if we can find a time outside of like the normal business day. So everybody in the class Stan lives in St. Ignatius, I think, but everyone else lives around here. So, oh yeah, you live in Plains, but you're here every day, so.
Stevensville.
But it's not like last semester we had someone in Great Falls, where they were actually like really far away and that it would be hard for them to come here. So any questions about any of that? I gave a lot of details. I mean, just kind of work your way through it. And if you have questions, so this is due Tuesday at midnight, so you can still have time to ask them last minute. Hopefully you've started before next Tuesday's class, but it won't surprise me if some people haven't. So
My question, will you come through the same
yeah. Okay.
One of those me.
So
Hi, Damon.
Mm-hmm.
it's probably Amber. How can I see?
Show us your boss. That was sweet.
Okay, now mine's cascading like that too now.
Show us your faces.
I'd like to figure out how to.
Click on
I should-
viewers.
I should be able to hear them and all that, like the whole idea with this Hangout, even though it's on air, is that you can interact with the people that are on it.
Forever.
I don't know.
Probably down to 1 pixel.
I mean, yeah, it goes way back there.
So if it decreases by like a quarter of a size, going from 1080p to 1080p. 5 by 4 divided by 4 divided by 4 divided by 4.
Yeah, but behind the scenes is still trying to do it.
Probably.
It.
See, like I'm supposed to be able to ask questions and then they answer them here. That would imply that it's live, right? I mean,
Yeah, hit it up.
Question, are you there?
Question out.
if you're there and you see this box, type an answer to, type something in there. Amber or Damon is probably the other one, but I don't know. I can't see who it is.
They probably aren't hearing.
Yeah, it won't let me ask a question.
Question. I don't
You
know.
ask a question
Come on, you
live
can
or
do it.
something? Was that
We gotta
Q&A thing
figure
right
this
there?
out.
Yeah.
Yeah, but that's what pops up. Ask your audience to submit questions. Like you're supposed to be able to ask me a question that I could answer.
Yeah. It
Tom,
won't let me.
send a question, Tom.
It won't let me. I already tried.
I don't understand. And then it says live, but there's a red dot next to it. Like, how far does it does it look to
About
you?
12 seconds. I already timed it.
Okay, well,
See what the delay
I don't
is.
know.
Like, I'm waiting for this to pop up now instead of being the Cascade one.
Okay. So today I'm going to go through chapter 6. Chapter 6 is,
There we go, now I got that.
okay. No, don't record. I'm good. Chapter 6 is called process modeling. So we're in the, so last chapter was requirements. This chapter's process modeling. We're in the analysis phase of the system development life cycle. So analysis, then design, then you implement it. The first chapters were about planning and selection. Now we're in the analysis, and then we'll move into the design. So this chapter is actually really good and useful stuff. I will admit, this is probably the chapter in this book that I have the least experience implementing in the real world. So we're going to talk about these diagrams, data flow diagrams, which are a really useful tool if you go into a business and you're going to try to help them choose or design a system. I've just never actually done one for a real business. I mean, I had my own business or the various things I've done, but they're pretty useful. So homework 2, we talked about that next Tuesday.
Okay, well, I had to log in for it to let me ask a question.
Oh, okay. And then did it come up?
I can get a question right now. Okay.
Yeah, how long does it
It's
take to
submitting.
come my way? It has this camera as guest joins hide their audio and video. See, it's implying that there would be audio and video. Broadcast the large video that I see. I don't know. I'm gonna have to do some more research, which I've done a lot, but I just can't hunt down stuff. Turn it up so I can, if it makes a noise. No, do not prompt for each slideshow. Okay, so summary of last chapter where we were talking about requirements. We talked about interviewing, the difference between open-ended and close-ended questions, preparation. So don't just go interview without thinking about what you're gonna ask. You want consistency. We also talked about observing workers, looking at business documents, some of the trade-offs of those. When you observe workers, they don't necessarily do the same thing that they normally would. We talked about joint application design, prototyping, business process re-engineering, which will come back today. A lot of times, once you diagram the data flow of a business, it becomes obvious that some part of the process needs re-engineered. Is that coming through that wall?
Yeah,
It's pretty loud, huh?
yeah. It's almost at the drum way up.
So disruptive technologies become part of this. So if you can, a lot of times, if you can implement a disruptive technology, that'll allow you to re-engineer a whole process. There's an example we'll look at today about processing credit. So this chapter, we're going to talk about process modeling. We're going to look at data flow diagramming mechanics, definition, and rules. I put a lot of information in these slides. Some of them I'm going to kind of gloss over because you sort of just need to look at it and look at it in the book. I put it in here more as a reference than something I'm going to go into great detail talking about on a few of these slides. We're going to discuss balancing data flow diagrams. So as you make these data flow diagrams, your inputs and outputs, which we'll see, have to be consistent. How do we use these as an analysis tool? And then we'll end up with a little discussion about decision tables, which I actually have used decision tables in my business for making decisions.
Wait, you use decision-making tables to make decisions?
Yes, that's what they're for.
That's pretty good. You just blew my mind.
You know, in high school, if I say something like, what? Well, something came up the last 2 days. Oh, I don't know. If I said something like, well, what's software engineering? You know, they always say, well, engineering software. You know, they just flip it, which a lot of times is actually a pretty good answer to the question, surprisingly enough. But so process modeling. So the idea here is that we use some graphical tools. Now, my guess is that some of the softwares you're going to look at probably have some of these tools. Certainly Visio, or what was the other one we used last semester?
The,
Hold on, Joey, I got.
oh, I know it. We used it too.
Come on, guys.
Huh?
No, not NetBeans.
Lucid chart.
Lucid Chart.
Okay.
Lucid Chart certainly, well, I'm pretty sure, I haven't like tried it, but I'm 99% sure it probably has data flow modeling as part of it.
It probably does. It has a lot of stuff.
Yeah, it has a lot of stuff. It likely does. So Lucid Chart, if you weren't in databases, is,
What other classes?
Java.
yeah, you can do UML in it. You can do, it's really good. I like it. We did database diagrams in it for database class. So the idea is we want to model how data flows through a system. And the system could be a computer system. Most of the examples in this chapter are like a business as a system. How does data get passed? I always use this bank example, but from the tellers to the various people, that would be something you could do one of these diagrams for. So the tool we use is a DFD, a data flow diagram. So this graphically illustrates movement of data between external entities and the processes and data stores within a system. So we'll see in the next slides that those parts, where does the data come from? What processes does it go through? Where is it stored? These are kind of all what appears in our diagrams. So for process modeling, we're going to model a system's process. So like I said, these systems can be very big in scope or very small. And then as we'll see, you can also dig down. You can start big and then break individual parts down into more detail. So utilize information gathered during requirements determination. So you've done your interviews, you've looked at the documents, you've observed workers. You have to do that first so you know what all the requirements are. Then you have the knowledge to build one of these diagrams so you can actually have a visual representation of what you've gathered. You're going to model the processes that go in place. Like, what does a teller do when they get a check? What do they do when they get cash? But also the data is modeled as part of this process. So what are you going to deliver at the end of this? A set of coherent interrelated data flow diagrams. So we'll see, and they have a very specific numbering system they use in the book to identify at what level are you looking at these. You start at level 1 and then you dig in more.
Is it like a level 0?
Yeah, level 0, 1, yeah. So context data flow diagram, which will show the scope of the system. This is the highest level one. Not a lot of detail, but it shows that overview of the system. DFDs of the current system. So you've gathered requirements about the current system. You want to model those. But then the idea is we're going to build a new data flow diagram of how we think we're going to improve the process. And the example that will come in, they take a whole bunch of steps out of a process and can make it happen much quicker and more efficiently. it seems like kind of a pain to diagram these, but it's much easier to both imagine how you're going to improve it and then show how you're going to improve it if you can have these two diagrams. Here's the original, here's how we're going to make it better. So the data flow diagrams ideally are technology independent. Like, it's not what is it going to be, a web flow of the data through the internet? Is it going to be an intranet? You're sort of independent of how it's going to happen, just that it's going to happen. So this new DFD will show that data flow. It'll show the structure and the functional requirements. So, or deliverables. Project dictionary. So a project dictionary is like it sounds, a dictionary of all the terms related to the project, any specific things that need defined. Computer-aided system engineering repository may or may not be part of this. So for data flow diagramming, we only need 4 symbols. This was invented by Gain and Sarson in 1979. So this has been around for a while. It's not necessarily even a technology thing, though it works very well for modeling flow of data in software. So Gain and Sarson. So the 4 symbols, we have a data flow symbol, which is basically an arrow showing which direction the data is flowing. We have a data store, which is basically a rectangle with one open side. That means we're storing data somewhere. Now, us as technology people, we would think of that as like a database or a flat file. It could be a folder. It could be a filing cabinet. It depends on what process and what system. Yeah, it depends what you're modeling. Now, the book shows a little bit of its datedness, but a lot of stuff is still stored in paper format, which is awful. Like I said, at the school, the amount of paper stuff I do, and then they tear the back off and give me the carbon copy of it. A lot of that still goes on. So
A lot of that stuff you can't even read it.
Right.
It's hard enough.
And then somewhere you assume they're storing those, right? So that would be a data store in a
Just find a pile of it in the cabinet.
big filing cabinet that never gets looked at again. I mean, but the thing is, like with the school, you do it all through paper, but then someone somewhere is entering it into a computer system, like at HR, like when I do a personal day request, or so it's convoluted. If you did a data flow diagram for some of those processes, you could propose a lot of improvements, I'm sure. Process, which is sort of a blue rounded corner rectangle, that means some processing of the data is happening. Something is being done, basically. It's a process. And then the final is a source or a sink. Source means that's an input to the system. Sink basically means it's an output.
So it'd be like green box is your interface, and then it would go to the process one as they were storing data. You would have an arrow going down to the store and then back to the interface.
Yeah, if you were modeling a computer type system, yeah, it would be more of a circular thing.
Yeah.
A lot of these are that like something gets handed to the teller, that's the source, and it goes out to the sink. Basically, it's like draining down the sink. It doesn't circle back necessarily. We'll see examples here, but
I know they had like a registry for classes book or something.
yeah.
It didn't make a lot of sense.
So data flow, so depicts data that are in motion and moving as a unit from one place to another. Now, like I said, we're thinking of data like in the internet or like the modern sense. It could be that someone stands up and carries a paper form across the office and hands it to someone else. And that's what you would observe when you were watching users. And if you watched a person do that 30 times a day, that's probably not very efficient, right? So
They probably have good link levels.
that's true. So, like I said, it's an arrow. It's this is the logical, easy part of it. Well, it's all logical, but it's the least abstract. you give a meaningful name to represent the data. So what, like that image had data flow 1. That's not very descriptive, right? Like, what is that? And you label it. So that's the data flow. The data store is that the data is at rest. It's stored. Might be data in a folder, computer file, a notebook. We draw it as a rectangle with that right vertical line missing. And again, you're going to label the name of the store as well as the number. So when you look at these in the book, it has like D1, D2. So every different storage has a different number in this diagramming.
So when you have like a spot laid out next to it that says what that source was, like, you know, D1, D2, D3, but that D1 would be like, wow, Captain Daniel's office.
Yeah, like here they have D2 goods sold file, D1 inventory file, like in one of these. Now that, you know, just, we probably won't need to do these for our projects because there's just not that much data flow, right? Like maybe, like you're saying, that circular input, it goes to the, you could do this for classes and how data passes through a system, but
So you could go out and have two different ways you could go. You could retrieve data.
yeah. Because usually you have a logic layer that does some processing of the input data, then it goes to the database, feedback comes out, there's some, you could use this similarly. So process, this depicts work or actions performed on data so that they are transformed, stored, or distributed. So process might be an analysis of the data. It might do a number of things. Rectangle with rounded corners. And again, we number the processes and we give them a name, like 1.0 record payment, 2.0 make bank deposit. And then as we'll see, we use that numbering. If we want to tear down the record payment process and get more specific, we can go beyond 1.0 to 1.1. And then you can do 1.2, and it's what layer of detail are we at?
1.1.2.
So if it's a 0 at the end, you're at the highest level, basically. Source sync. So I think source sync is the hardest part to kind of get right about this. It seems easy, but it's easy to mess up, and the book shows a good example on page 157 of how you can kind of mess up how you think of source and sync. So source is the origin and the destination of data. Sometimes referred to as an external entity. So the idea is if you're going into a business and modeling a system, these are completely outside of the business. They're not like a different department within the business. They're like the customer. Customer is not part of the business. They're completely outside. This is a square. The name states what the external agent is. So like this diagram I'm looking at here has customer, has bank. It's a noun, basically. Because they are external, many characteristics are not of interest to us. We don't, what leads up to that source, we don't necessarily care about, just that it's a source. We can't follow a customer home to study what they do before they come into a system. You could, but it'd be creepy and you'd probably get in trouble. So yeah, you pull up with the black van outside their house to
See, they expect
watch.
a black man. They don't expect a white man.
Yeah.
It's not illegal.
No, it's not illegal. It's just creepy.
Hey, you're a private investigator. I do it to Aaron all the time.
So here's a diagram. This is actually the one out of the book. So the top one is incorrect. So the idea here is that we have a customer. That's the source. They're making a payment. We're recording that payment. This is a process. We're recording that they made that payment. And then that gets passed on to a bank deposit, which goes to a bank. The bank is the sink. That's outside of this system. So this system is, what kind of organ, does it say the organization it is in here? Basically, you're a business that's taking a payment. You're the power company.
So then the
You record a payment, you deposit it into the bank. The bank is outside of your business. That's an outside entity.
So then the bank would have their own little scheme where it then went to the store, the data store.
Right. But we don't care because it's external. Yeah. Now, what's incorrect about this top one is, so once you make a payment, eventually you're going to need to get a receipt, right? So this is kind of where this is circular. They put that this goes to the accounting department and that's an external. It's a rectangle, it's a sink, but it's not, because accounting department is within this business. It's within this system. Really, it should be like it is down here. A new process that's update customer master. So update that they made a payment and on this date, et cetera, then get a receipt back to the customer. And then you're going to store some data in this customer master record. So
But the top one would be right if they outsource their accounting.
if accounting was outsourced, that could technically be right. Yeah. So the book says in here that, many times students become confused about whether a person or activity is a source, sink, or a process. Because it seems like an accounting department, that's a thing, that would be a sink. And here it's actually a sink and a source, right? Because it's going both ways. But that's really a process. These things need to be external. That's kind of what separates them to be a source or a sink. So data flow diagramming, context diagram. So context diagram shows the data flow diagram of the scope of an organizational system that shows the system boundaries, external entities that interact with the system, and the major information flows between the entities. So this is the highest level. You're taking a whole system and showing everything. We call that the context diagram. That's because, like it sounds, it gives you context of the business. Level 0 diagram is a data flow diagram that represents a system's major processes, data flows, and data stores at a higher level. Level 0, these have zeros at the end. They're a level 0 diagram. If we wanted to model this process of making a bank deposit, because that has a process, right? We could do another one of these that splits off. It would be a 2.1 diagram, because that's modeling the specific details about this. So this is a level 0 diagram. So the book goes through a really simple example of making a data flow diagram. They have this fictional business that's Hoosiers Burgers in Indiana. Yeah, which makes sense. So, and they're going to model this food ordering system. So they're going to give a context diagram. A context diagram doesn't have data stores because we're looking at a high level, right? We don't need to see the details. The details we would tear into. So here's a context diagram. Includes one process, which is that someone's ordering food. It has 4 data flows. So a customer comes in, they make an order. That enters this process. Out of that process comes a receipt. So that comes back to them. That's 2 data flows. When you order food, that has to get passed to the kitchen. And you're going to have some reports that go to management. Now, these 2 are internal to the system, right? A manager and a kitchen are part of the business. But this process we're diagramming is a food ordering system. So even though these are within the context, for the purpose of this, we don't really care what the kitchen does. We're not even showing how does the food get to it, like it's.
So if it was like that, though, the customer would be the green one, and then it would all be processes, and it would all loop back around
To the customer. So right now on this one, we're just looking at the food ordering system within this business. So that's a context diagram. It's not, there's no data store. We're looking at this food ordering from the highest level. The next step is to break down the processes. So we only have one process here, but we're going to break that down. So 4 separate processes to do the food ordering process in that first one. So the customer receive and transform customer food order. So either they're entering it into a computer or they're writing it on a
Transform it.
one of those things that they stick up in the kitchen window. Ticket. Yeah, there you go. This part looks like that other one, right? This is basically
Just a couple more.
the data flows. It's just, then we're breaking it down more. So you've transferred the data goes to the kitchen, but now you need to update your goods sold file. So you've sold 2 cheeseburgers. You now have 2 less burger patties and 2 less buns, right? So that goes into the inventory data. Goods sold goes into your accounting system for report, so you can know how much did we sell in a given day.
How much do you need to get out of the freezer for the next?
Right. So goods sold data, that's stored in a file. Hopefully it's stored in a computer file in today's day and age. Same with inventory, has an inventory file. Hopefully this is an inventory system and at least QuickBooks or some kind of accounting system.
At least Excel.
Yeah, something. And then these come back together. So we're the daily inventory has been depleted, the daily goods sold amounts. Now, what do you hope happens with these?
That they get filed.
Yeah, but think about
Forward back.
they should be equal, right? What happens if these aren't equal?
Then Tom's stealing burgers again.
Yeah, someone's stealing burgers, right? And not paying for them. If they're not equal, we used more inventory than we sold, something's off. So
Employees are-
I assume at McDonald's, if you eat something, it's got to go through the system, right?
We actually had to go out and order, when I worked at the restaurant, we had to go order from the servers and they punched it in. And
Right.
then he came back and said, hey, that ticket that just came up is mine.
Yeah.
What do you mean by like going through the system? Like, yeah, you put it.
Like if you want to eat a Big Mac, you still have to enter it in the computer.
Oh, yeah, no, yeah.
Yeah.
Anything you order goes through the system.
Yeah.
To the computer screen.
Right.
So they know what to make, like.
Yeah.
Even,
Even if it was comped for whatever reason for an employee in a business,
Ours were-
you still want it to go through because then
Yeah.
these match. The dollars might not match, but the number and the amounts match.
Yeah,
Right.
it had like a certain button you press and it would say employee meal and it was automatic.
Yeah.
Right.
Anything you
Yeah,
spent over
the
like
managers put in a code
Yeah.
for employee meals, so.
And then now we're back to the same sync of it's going to the manager. They're getting reports on inventory and then they can order more. So this is just breaking it down a little further. So this diagram is a level 0 diagram because they're all point zeros. The context diagram, they're numbering the processes with zeros. They're not 1.0s, they're just zeros. So I don't know.
It's update file.
That one's even
3.0.
more basic than this one.
Right. This is one layer down. And then we could take
Can you make that
this
thing
process-
broken down?
and we could go further. And then we could take this process and we could go further. Now, eventually you run out of like further detail you can provide, but
That one.
there's probably something for this, right? Like,
Well, because the manager doesn't just like get everything, oh, okay.
yeah. So, I mean, you can see how that can get broken down more.
Anyway.
So there's a whole bunch of rules that apply to all these diagrams. And this is where it gets pretty detailed. And I'm not like expecting you're going to memorize these rules, but just to at least see them and be aware. The basic rules, though, you should have a good idea of. Inputs to a process are always different than outputs. It's kind of common sense, but if data flows into something and comes out the other side exactly the same, what was the process? So in burgers, orders coming into this process, the receipt coming out, it's not the same. It's different data. It has a cost to it. My order going in is I want a Big Mac. My receipt is I got a Big Mac and exactly. So it shouldn't be exactly the same in and out. Inventory data comes in, it's formatted now. So it's different. It's not just exactly the same, or it's not a process. Objects always have a unique name. So you shouldn't have two things in your diagram with the same name. So in order to keep the diagram uncluttered, you can repeat data stores and data flows on a diagram. So how do those jive together, right? Like as a rule. I think this one is a little bit confusing to me. I don't know, I read this in the book, or did I see it? There is no reason to have two processes with the same name. You may repeat data stores. When two arrows have the same data flow name, you must be careful that these flows are exactly the same. So the idea is two arrows can have the same name if they're identical data. So like if you have a receipt that goes from one process to, it wouldn't be to a process, it can have the same name. I don't know, I think that's confusing, but it's a mistake to reuse the same data flow name when two packets of data are almost the same, but aren't the same.
Say receipt process 1, receipt process 2.
Right. So now the book goes into like very specific rules. No process can have only outputs. That would be a miracle, right?
Just something that says there and outputs.
Yeah.
Little stuff.
Right. No process can have only inputs. That's just a black hole. A process has a verb phrase label. So a process should be an action, right? For the burger one, update inventory file, update goods sold file. So those are actions.
Produce management.
Yeah.
Yeah, they all have a verb kind of starting them. Data stores, data cannot be moved from one store to another. It doesn't just magically jump from here straight to here. If it did, there's some flow and some process, right? Otherwise, why would you put it in a folder and then move it to a different folder? That would make no sense. Data cannot move from an outside source to a data store. So it doesn't just flow straight from the customer into a data store. It's got to go through a process. Data cannot move directly from a data store to a data sink. So if data is going to come, if you have a database, it doesn't just jump from there to the customer that's outside. It has to go through a process to get to them.
You gotta upload it to Moodle, send it to Daniel.
Yeah. Data store has a noun phrase. So data stores are nouns, processes are verbs. Source sink. Data cannot move directly from a source to a sink. Otherwise, it's not even part of the system, right? Like,
It's just process.
yeah, it has nothing. It's outside. A source sink has a noun phrase. So nouns for data stores and source and sinks, verbs for process. Data flow. So here we have A, B, C, D, all the way to P. So there's a bunch of these. The data flow only goes one direction. You can have a fork, but it has to be exactly the same data going to two or more processes. You can have a join, but it has to be exactly the same data coming back together.
So, like if the customer had a receipt and they kept the paper copy and they had put it into their computer, you could like
Yeah, I think that would work.
one into a store, one into a process.
Right. Data flow cannot go directly back to the same process.
So
It doesn't just loop. That's that'll crash your computer, right?
divided by
Data flow to a data store means update.
So
That kind of
now
makes
have this
sense.
new
Like
database.
if it's going to go in, it's updating, right? If it's flowing into a data store. A data flow out of the data store means you're retrieving. So you're doing a select on a database versus an update or an insert. A data flow has a noun phrase. So we end up with 3 nouns and 1 verb. The only verbs are processes. So we've been talking about these layers of the diagram. This is a process called functional decomposition. So an act of going from one single system to many component processes. So as you break down the processes, you're decomposing the system. It's a repetitive procedure. You basically do it until it's not logical to do it anymore. The lowest level is called a primitive data flow diagram.
Gotta get
So
it
then-
in voice code form.
Yeah, it really, this part reminds me of databases and normalization.
So everything is a functional dependency.
Yeah, right.
Its own table.
Yep. So the top level is a context diagram. One level down was the level 0, and then we have the additional levels until you get as far as you can. That's primitive. Level N, these are all the ones in between. So level 0, but then you have level 1, blah, 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 blah. DFD, that is the result of N nested decompositions of a series of sub-processes starting at a level 0. And how many is N? If you diagrammed Coca-Cola, N's going to be big. If you diagrammed,
Mom and Pop's restaurant.
yeah, it's going to be not very many probably. So when you're doing this decomposition and you're breaking these down, the big idea is that you have to balance these diagrams. So the number of inputs and outputs to a process have to stay the same. So if at the highest level there was one in and one out, and you break that process down into more detail, there still has to be one in and one out. It has to jive with the layer above it. It can't all of a sudden have 3 outputs. So this is called balancing. So the Hoosier burgers. So in that 6-4 diagram, which was the one we had, there's one input to the system, which was the customer ordering. There was 3 outputs. The customer gets a receipt, the food order goes to the kitchen, and the management gets the reports. If you break down any of those processes, it has to jive within that. So this is leading to the next slide, which has the diagram. We have the same inputs and outputs. There's no new inputs. We can say that it's balanced. So this isn't a burger example, but this is just a simple. We have a source, we have a process, we have a sink. This is the context diagram. Now we're going to go to level 0. We have a source 1, a source 2. This is wrong, right? This is an example that's wrong. I'm like, wait a second, this doesn't look right. This is unbalanced because we're taking this process and we're breaking it down, and now we're saying there's 2 sources. But here there was 1 source. There has to be 1 source. Even if there's 100 steps within here, there still has to be 1 source and 1 sink to match this. If this one had 3 sources, then this one would have to have 3. Because this is magical. So you don't just blob these 2 together at this level and say they're 1 just because it's at that highest level. If it's a unique source, that needs to be encapsulated in here. So these are not balanced. Totally confused myself because I thought that diagram was supposed to be balanced when I put it in there. So we can split a data flow into separate data flows. So you can have a flow that's payment and coupon. So I buy the Big Mac and I give a coupon and some money. When you break it down, you might have payment and coupon as separate flows. You can have more flows, but the source is still the customer, right?
Those of us monopoly talking about getting a Big Mac for free.
That's true. Then there's no payment. So we had through P, now here's QRST, the advanced rules. These are pretty complicated. So, I mean, it's talking about not having data flow lines cross, and we're not,
Just making it visually look good,
yeah, we're not at that
a lot easier to track.
level. So they're advanced rules. So when we draw one of these diagrams, And I recommend, because I didn't put a lot of slides, there's more examples in the book about the balanced diagrams. But the simplest idea is the same number of sources and the same number of sinks into a process. So in drawing these diagrams, they need to have completeness. So they need to include all the components of a system. Each component must be fully described in the project dictionary or case repository. So the idea is if you have a component, the dictionary lists that component with more specific details. So you can look at the diagram and go to the dictionary to get more about that. Because obviously the diagram does not hold much information other than a label. They should be consistent. So, I mean, it's just as you break down these layers of the diagrams, they should be consistent with each other. Timing, just be aware, we're not putting timing really in these, right? We don't, how long the burger took to get made and the order, that's not part of the process. So you just try to draw just assuming it's, I mean, they say the system has never started and will never stop. It's just ignoring time is what they're getting at, because that's not part of this process. You're not looking at, well, this takes 3 minutes and this takes 1 minute, and how do we time it out and how could we improve it? That's kind of a different analysis of the diagram. Iterative development. So just the idea, you're not going to draw it once and it's perfect and that's it. You're going to refine it. That's kind of obvious. Primitive DFDs. So when you've broken it down as far as you can get to, that's the lowest level. A decision has to be made when you stop that process, right? Like when it can't be broken anymore.
Or, all right, enough type thing.
Yeah, I mean, there's a certain point where maybe you could break it down, but there's nothing to be gained from.
Nothing that's really just not looking at it and going, oh, well.
Right, right. So that's sort of an experience thing, right? Like you just would know when it's broken down far enough. There's not like a hard and fast rule to go by.
Like it goes to the employee, but you don't need to know that the employee then walks in their car and then drives home and then comes back.
Yeah, exactly. That's going too far. So, I mean, I said there's not hard and fast rules. There's guidelines. They call them rules. But when each process has been reduced to a single decision, so it's like in, out, it's stored, there's not any more complication, you're probably far enough. When a data store, the input is like one thing, like I'm putting this one piece of data in, not like a whole big collection of data, that's probably broken down far enough. This is the big one though, when the system user does not care to see any more detail, that's sort of up to you. It's just far enough. And it's similar to normalization. You know, you could keep going way past where we went, and you get to a point where it makes no sense to go further, right? And then we talked about denormalizing databases. Very similar idea. More rules, blah, 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 blah. I mean, I'm not going to go through all those. So, whole bunch about making these diagrams. But what do you use them for? So one thing you use them for is what we call a gap analysis. So you try to discover discrepancies between two or more sets of data flow diagrams or discrepancies within a single data flow diagram. I have done a gap analysis before. We have a pathway. They're called these big sky pathways, and it's showing a high school kid, if you take these classes, these ones are dual credit, and like here's the pathway and how close you are to having an associate's degree by the time you're done with high school. And you do a gap analysis of all the courses and the flow, the pathway through that to see if there is things that are out of sequence and don't make sense. They call it gap analysis. So you're looking for those discrepancies.
So like looking for a prereq.
Exactly. You say that they should take this course when they're a sophomore, but it's not possible because they wouldn't have the prereqs. Yeah, like a lot of that kind of stuff. So gap analysis is one thing. Just identifying inefficiencies is another tool to use these for. So the example in the book is about IBM credit. So they had this process. You would call a salesman person to get credit approval, a salesperson. And the way they described it, it's 6 people sitting around a table waiting for the phone to ring. And then when it rings, they would log a request for credit. The documentation would be requested, which gets pulled from these credit files, this data store. That's the check creditworthiness. Then it would go, you'd modify the loan agreement based on their creditworthiness. These are all processes. Request status and loan documentation. Then you're going to determine the interest rate, which comes from another data store. Then it's going to be documented and you're going to create a quote letter. And then it's going to go out. Now, the salesperson's at both sides, but they're outside of this internal system. So they're the source and the sink, because then they get it back and they need to contact the person to say, did you get approved for credit for this loan?
And then they would put it into a store.
Now, this took 6 days. And then these guys came in and analyzed it using a data flow diagram to see if they could improve the process. Now, they looked at it and they found that in order to go through that 6 days, there was 90 minutes of work actually done on that request. It just took that long to make its way through those systems. So they cut out a whole bunch of that and just said the salesperson makes the request to, and it's one salesperson, makes it a request to a person who's just processing that contract. They can deal with the credit files. They can deal with the interest files. They can get data from specialists. So you don't have all these people that are kind of doing a whole bunch of stuff. And then it goes back to the salesperson. And it takes 100 times more can be done. So instead of it getting passed and then it has to sit there and it has to go here and it has to go here, data's flowing around. These are probably paper, files. Banking, still a lot of that stuff's paper. And of course, this was in the 90s, 93 that they did this. So this was way back. Now here, there's only one real process that one person is dealing with, and it speeds it up. The book does a good job of kind of going into that if you take a look at that section. So, and they call this a business reprocess it because they're completely going in and saying, throw out how you did it and do it this way. So you're blowing up the whole system. How many slides do I have left on here? Okay, not that many. Data flow diagrams do not show the logic inside the processes. That's kind of a different thing. So logic modeling involves representing internal structure and functionality of a process depicted on a DFD. So you have a process, like the burger one had, that basically it was just this food ordering. It got passed to the kitchen and the managers, but they didn't go into what that process was. So logic modeling would kind of show that in more detail. And you can do this with decision tables. So basically a decision table it's a matrix, which is a table. And you represent the logic of the decision. So you specify in the table the possible conditions and the possible outcomes, the actions. And this is good when this is a complicated process. If it's not complicated, it's kind of pointless. So there's 3 parts to this. Condition stubs, which lists the condition relevant to the decision. Action stubs, which given a condition, what's the action? What's the condition that comes in? What's the action that happens? And then the rules. So you have rules that govern these decisions. So I mean, this gets pretty detailed. You have some indifferent conditions. So these don't really affect the action. So there's some conditions that don't have an effect. So to create these tables, you name the conditions and values, the values of the conditions. So you name all the possible outcomes or actions, list the rules, define the actions for each rule. So given this condition with this value and this rule, what's the action that's going to happen? And then you make this table. So these tables look like this. So this is a decision table for this Hoosier Burgers inventory reordering system. So the idea is, when do you reorder buns or burgers? So
Hopefully weekly.
P and N are perishable and non-perishable items. We have D, which is weekday, W, which is weekend. And then is it academic year, summer, or holiday? Because the idea is this is at like University of Indiana or something. So it's way more busy during the academic year. So here's a list of the type of items. Is it perishable, non-perishable?
That doesn't say what the items are.
It doesn't, but these would be represented. You would know what they are by the numbers, I guess. This is a little different than how I've actually done these before. Time of the week, season of the year, and then basically, let's see, the reduced is easier to see this. So here's like for this, there's a minimum order quantity that you have to do to get this non-perishable item. So I don't know, forks, plastic forks. You need to order at least 1,000 at once.
Or invest in real silverware and save money.
Now it kind of makes sense. Most of the non-perishables have a minimum order quality. Do you need to reduce during summer? So this perishable item you need less of in the summer. Do you order these every day? This is a standing daily order. So this next one just kind of reduces it down. And then how the heck do you make a decision off that? Where is that in here? Not too far. So it says, for example, for rules 3 and 4 in that figure, it would be important for the Mellencamp's, that's who owns this, to account for the summer reduction, to modify the existing standard order for the supplies. It's basically just taking a whole bunch of things and boiling it down into this kind of table where it's easier to see. Given this item,
They're boiling it all. No wonder it's perishable.
yeah, given these rules, how should I order inventory? You know, I always think of it like they're really like truth tables, right? That we looked at last semester, 0, 1, 0, 1. You do ands, ors. It's really similar to this process. In a little different format, you can use these decision tables for kind of like a pros and cons analysis. The book mentions that all of the stuff in this chapter about modeling these with data flow, you can do it for electronic commerce projects. And I've touched on that all through. You can model the flow of data from a website into your web server. The web server is going to do some processing. That's going to go to the database, which is going to be on a different server most of the time. That's a data store. Obviously, you could model all the processes that these go through. When you get into these bigger web applications, you know, in database we had PHP and we had SQL Server. You might have 5 different programming languages and certain ones run to process certain things. That's really common where they have back-end logic written in a number of languages that data will pass through.
Does it seem that PHP stuff have HTML in it too?
Yeah, you're embedding HTML in it. Yep. So I mean, you can model these. There's an example in here about the Pine Valley furniture, the same one that's kind of been coming up that you can see. So here they're just kind of showing like the Pine Valley. Remember, they're showing furniture, selling furniture. So processes, catalog, purchase, shopping cart, checkout, user profile. This is the, pages of the system, and you could model out all that process. Each page basically becomes a source, right? Depending on what level you want to do it at, a source of data. So summary, and that's really kind of for next time. So, I mean, again, this is a lot of just kind of getting familiar with this process. The problems I gave you to do for homework, 5, 8, and 9.
5, 8, and 8.
5, you're going to look at potential violation of rules on a diagram they give you. Same for 8, you're going to list 3 rule violations on the DFD. And the same for 9. You're actually kind of just analyzing some examples and there's a bunch of them in here. I'm not having you actually like make your own at this point. I may make you for your project do something really simple, even though the scope of our projects, this is kind of overkill for, likely, but.
So with our overview of our projects, do you want it in a Word document, or do you want us to just verbalize?
Word document. Yeah, just type it up. Just type it up. Or a PDF would be also fully acceptable.
I'm gonna put it in Excel.
I was just thinking that.
Just gonna figure out which cells they're in now.
Yeah, right. Hide them like way out there.
A super gnar math problem.
Okay, signing off of the feed here, so
Solve the equation to figure out which cell.
yeah. Email any questions you have my way.